Good morning. This is your stats sensei, Mr. Spensei, and we are going to do a warm up on the normal distribution and also central limit theorems of the distribution of means. So, suppose the mean room and board expenses per year at a certain four-year college is $7,850. So that's important because we just learned about the mean. So the mean is 7,850. You randomly select 9 dorms, so we have a sample size of 9, offering room and board near the college. Assume that the room and board expenses are normally distributed with a standard deviation of 11,000 or 1,125. So we have a mean of 7,850, a standard deviation of 1,125, and we're looking at a sample of size 9. But the first question is, what is the probability that a random dorm room and board of having a random room and board of less than $8,180? So when we look at this, we're drawing our picture, and we have 7,850, and then we have less than 8,180. Oops, 8,180, that's above 7,850. So we're above and we're shading this way because it's less. So we know this is the correct drawing, shading below. And we know that our mean, but the question is, what type of test? Is this going to be a norm CDF or is this going to be a Z test? Well, it says a random dorm, so we're talking about 1. If you're talking about 1, you're going to want to use the norm CDF. So norm CDF, lower bound, negative infinity, upper bound, 8,180. So this is my lower, this is my upper. And then we have a mean of 7,850. And we also have a standard deviation of 1,125. So let's go ahead and drop that into the calculator. So second vars, normal CDF. There's no infinity key, so we're going to use -9 raised to the 99th power. My upper bound was 8,180, which is above the mean, so we were expecting it to be more than 50%. And then we have a standard, the mean of 7,850, and we had a standard deviation of 1,125. And when we do that, we end up finding 61%. So 0.6153, and that makes sense because it should be greater than 50%. What's the probability that the mean room and board of the 9 dorms is less than 8,180? So here we're talking about the mean. Once again, we have the exact same drawing. Nothing changed, except maybe I'll draw it right this first time. So 7,850. My upper bound is 8,180. And once again, we're dealing with less, so we're also still shading to the left. So we're going to negative infinity. So that's a quick correct drawing. But in this case, instead of working with a norm CDF, up here we were working with 1 dorm. Here we're working with 9, and we're talking about the mean. So we're talking about the distribution of X bar. All right, the distribution of the averages. So we're going to need to use a Z test here. In the calculator, the very first thing it's going to ask for is the mean, which is 7,850. Then it's going to ask for the standard deviation, which is 1,125. Then it's going to ask for our X bar, which in this case is 8,180. Then it's going to ask for our sample size, which happens to be 9. And then the last thing is going to ask for the direction we're shading, and we're shading to the left. So we need a less than symbol. So when we go to the calculator, we're going to go to stat test, arrow over to Z test, and we're going to enter and press that information. So 7,850, 1,125, X bar of 8,180, sample of size 9. And I should say this before we go much further. We can use a sample of size 9 because it's normally distributed. If it had not been normally distributed, if it had been skewed, we wouldn't have been able to use it. We would have had to have a sample of size 30. All right, and we can go ahead and press calculate. And we find that 81% or 0.8105 is our answer. Finally, what is the probability that the mean cost of a sample of 4 dorms is more than 7,250? So again, we're drawing our picture. Our mean is at 7,850. This is 7,250. And we're looking for more. So we're shading up to positive infinity. All right, with that said, the question is, what type of test are we running with? A norm or a z-test? Well, this says mean, and we have a sample of size 4. So this lets me know I'm going to be working with a z-test because the mean tells me we're working with the distribution of means or the distribution of the averages or the distribution of x bars. And we also have a sample of size 4. And anytime it's multiple, it's going to be, it's most likely a z-test. So our mean is still 7,850. Our standard deviation is still 1,125. Our X bar is 7,250. N is 4. And we shade it up and to the right, which means we have a greater than symbol. So stat, test, z-test. And the only thing we changed is 7,250. Our sample size is 4, and we're going with a greater than symbol. Once again, we should be over 50%. And we're at about 85%. So 0.8569. All right. Thank you for watching and hope to see you on the next one.